We good?
Yeah, we're good.
Awesome. So we're back. Um, Next, we're going to work with cross validation, which is essentially validating our model. So in the last video, you saw that we had um, like a second model, which I called mod.2, with just predicting wins using fielding percentage, runs scored, and uh, ERA. So now we're going to do some cross validation, which this is just a bunch of code for cross validation.
It does. It removes the. What does it remove?
Right. So we're going to look to see whether this model is going to be our final model or if we need to take out any more variables.
So why can't you? This is just a challenge. It's challenge day. Why can't you just use the ASIMP to do this?
Step AIC?
Yeah, the thing they would use to eliminate variables earlier.
Yeah, so Step AIC, in doing it once already, Step AIC has already eliminated 5. And so if we were to run Step AIC again, it would not eliminate any more variables. And so while we could leave it there, we need to just make sure that our cross validation allows us to make sure that we're at the best model possible. Whereas Step AIC only aims to eliminate multicollinearity. And so we have already done that in doing this. Step AIC then just goes to make sure beyond multicollinearity that we have the simplest model possible.
So now we have to obviously so what's this called? Co-variable again?
Cross validation.
Cross validation gets more detailed with eliminating variables. It's down to I don't know what decimal place or what thousands or hundreds of thousands essentially of decimal to eliminate the next variable, which is going to be fielding percentage. Right, we're about to figure out. Okay, we can eliminate.
So you can see here that the model felt strongly about fielding percentage with its inflation with its estimate. So we're going to essentially just go look at it, and that's what we're going to be testing here in cross validation. So we'll do two sets of cross validation. And this first one you see here that we have fielding percentage in it, and then we'll run it again without it. So let's see what this gives us. So essentially, what I asked for was an R squared, as given by this line, and a summary, which was printed out for us. But the summary is just the same summary as this one right here, just so I could see it again. So essentially, we have a R squared of a cross validation R squared.
It went down.
Pardon?
It went down a tenth.
Right. So the cross validation validates this model at 0.47, 0.747.
Yep.
Which right now that doesn't mean a lot to us until we run it without the fielding percentage, which I will do now. Command T. And then I've got to go in and add the object again to call the variables. And so now you can see this time that we have no fielding percentage in this model. Where did I make mod.3?
Does it tell you to delete the fielding percentage essentially because it's at 1,000?
It does, yeah. So that's the one. That's this 1,000 right here is the one that it tells me that I should pay most attention to. And so when we run this, yep. See,
error.
You get this all the time when you aren't paying that close attention. Where is it? Not finding that.
Wins not found, good sir. Data new wins. Go up to the first one. Data new wins. Scroll down again. Baseball 10. Data art. Oh, scroll down. Copy. You just copy stuff from above, right? Oh, yeah, there it is. I don't tell us a line number. That's the only problem with this. I guess it's not that much. Not that many, so. Good eye. Good eye, mate.
Appreciate that. I used to take a lot of walks back in my day. There we go. Okay. And so now you can see this printed an R squared of 0.749, which is higher than our previous one of 0.747. So our R squared between the model without fielding percentage went up by 0.002, which, I mean, in the grand scheme of things, isn't the greatest increase, but it still makes our model more simple because by deleting fielding percentage, our cross-validation actually went up a little bit, and we still don't lose that much on our R squared as far as the model is concerned. And by validating the model, we're able to see that cross-validation produces a higher R squared.
All right, great job. Next call of cross-validation for you guys. We got to the nitty-gritty. Had to take a step farther from a what, Jeremy?
From step AIC.
To step AIC to cross-validation to get our model more simpler to predict the future of Major League Baseball. So, stay tuned to the next video.